Ladies and gentlemen, welcome to Unit 3, Lesson 7, Part 1. This is a preliminary lesson to help us with finding the sums and differences of fractions with uncommon denominators. And so what we're really thinking of is, what are some other ways I can write 1/2? Or what is 1/2 equivalent to? And so let's visualize this for a moment. I kind of talked about it a little bit, but let's say a person that I know, Billy, he ate 4/8 of a pizza. He was so hungry. And so what he also ate, he actually ate 2/4 of that pie. But if I look at it, I can also divide it into 1/2. Because this looks like 1/2 of the whole pizza. Now, did I change the value? No. But all I did was I kind of looked at it and I saw that, okay, this is a group, this is a group, this is a group, and this is a group. And so those are 4 different groups, and he ate 2 groups of the 4. So 4/8 is the same as 2/4, and it's also the same as 1/2. 2/4 is the same as 1/2. And so we see how it's broken up into 2 equal parts when he ate that piece. So he had 1/2 of the pizza, he also had 2/4 of the pizza, and he also had 4/8 of the pizza. They all mean the same thing. They're equivalent, but their identity looks different. So let's take a look at the analytical parts of it. When we're talking about numbers, what we're really doing is we are using the identity property to change what it looks like, but its value remains constant. The identity property of multiplication states that any number multiplied by 1 will still be that number. So what I mean by that is this. If I take 5,000 times 1, it's 5,000. And so what are some other numbers that we can make as 1? What's a fraction for 1? Well, 2/2, right? Or 3/3, or 8/8. These are all 1 because I have a denominator of 8. That means I have 8 parts, and 8 parts were shaded or used or eaten or turned red or something like that as a fraction. The whole thing was used. And so if you have the top and the bottom number to be the same, that means 1. And so if I multiply any fraction by 1, it will still have the same value, but if we multiply it by a fraction of any one of these, where the top and the bottom are the same, it's going to change its identity. It's going to look different. So let's put that into practice. If I take a look at this, when I multiply a number by a top and a bottom, it's the same as multiplying by 1. We got 2/2. That means 3 times 2 equals 6. 5 times the same number equals 10. So that means that 6/10 is the same value as 3/5. I can do the same thing with 8/10. If I multiply that times 3/3, that's going to give me 24/30, which is the same exact value as 8/10. The identity is different. I could also, if they share a same factor, 8 and 10 share a common factor of 2. So if I divide them both by 2, I get a reduced or simplified fraction of 4/5, which is the same value as 8/10. And I can multiply that back out to be like times 20/20. And that's going to give me 80/100ths, which is the same value as 4/5. And so, which is also the same value as 8/10. So I can make a million different equivalent fractions for any fraction when I multiply by 1. And if that's the case, I'm multiplying by 2/2 or 20/20 or 12/12. Any number top and bottom is equivalent to 1. And so when I create an equivalent fraction, its identity will look different, but its value stays the same. You're going to need this for when you're adding and subtracting fractions and mixed numbers with different denominators, different bottom numbers. We need to make sure they're the same before we can add them. So you need to know how to do equivalent fractions.